In 2015, Google has released a very interesting paper in which they explain why they use the Monorepo. The Monorepo is an extremely large single monolithic repository that provides the common source of truth for tens of thousands of developers in Google all around their code. It stores billions of lines of code. This means that when you work as a developer on this repository, then you are working with this single semi-Git repository with billions lines of code, and there are tens of thousands of developers working on this very same code base. In this research paper, Rachel Potvin and Josh Levenberg from Google shared their experience and their thoughts about this way of working with a repository, with a large, huge monorepo. They scanned the advantages as they see it and also the disadvantages, and in general, the general workflow of the developers with this vast, huge large monorepo. So let's see what this paper is about. The article itself goes through the scale of this code base, the monolithic source repository, and the reason that they have chosen this model. They start by describing that they have chosen in Google to use the trunk-based development strategy that supports their workflow and keep Google's code base healthy, and we'll discuss this further on. The paper then goes ahead and describes the scale that this monolithic software repository handled. At least in the year 2015, 95% of the software developers worldwide were using this ultra-large scale repository. And this, as they claim in the paper, provides evidence that a single source repository model can be scaled successfully. So just think, if you are a small startup with a few people and you try to think if you need multiple microservices, it's not exactly the same thing, but if you might think, maybe I need to split my services or split code bases so that different people or different teams can handle it more wisely. So see, in Google, tens of thousands of people are using the very same code base repository. So of course they have their own tools, but this does not mean that you need also these tools, because this is really a huge scale. In this repository, they had 1 billion files. And also they had 35 million commits, spanning Google's entire 18 years of existence at this year. The repository contains 86 terabytes of data, which includes both the source files and data files as well. There are 2 billion lines of code in 9 million unique source files. It contains also the documentation and data files. Everything is in this monolithic code base. So in the past years, there was this hype of the microservices. It's still a viable option, but see how they took the different sides. So yes, microservices does not mean multiple repositories, and you can have a single monorepo with microservices, or multiple repositories with a single monolith. Okay, this does not implicitly say one or another. So they have 50 million lines of code that were changed in 250,000 files every week. So every week they changed 15 million lines of code in this single repository, and also they changed 250,000 files every week. On a typical workday, they have 25,000 software developers, and this is 5 years ago, which are doing 16,000 commits. And the number of reads from this repository, so if you do a checkout or read a file, or an automatic system reads a file, then it's 500,000 queries per second for this monorepo. To sum up, the scale of this repository is 1 billion total number of files, 9 million number of source files, 2 billion lines of source code, 35 million commits, and 86 terabytes of size, and 40,000 commits per workday. And as they said, this is ultra large scale monorepo. So they say in the paper that they were not able to find any commercial or open source system to handle this, so they needed to create one. So the original developers decided to go with the monorepo, and then the scale really increased exponentially, so they needed to create specific tools for that. So they created, and in the paper they say that they created two main tools. One is called Piper, and another is called C2C. So Piper is the service that stores the large repository, and it's implemented on top of the Google infrastructure, which was originally on top of Bigtable. So the Piper is distributed over data centers in Google, and it's relying on the Paxos algorithm in order to guarantee consistency across replicas. It's also utilizing asynchronicity, so that when you do operations, you don't need to wait, assuming you don't need an immediate response, and also caching layers. So it provides you basically with a fast, semi-like file system for you to work on. This is the repository. In addition, because they store everything in this repository, so think also the Google search algorithm is in this repository. So basically, each of the tens of thousands of developers could just go and look what is the algorithm, and they would know it. So there is security, also security considerations also in this monorepo, where most of the developers could see almost everything except for specific configurations and business critical algorithms that are more tightly controlled in security. They have also logging for everything that happening there, and in general, they have the workflow where, yes, if you as a developer want to work on this monorepo, then you fetch it, but it doesn't fetch really anything. And when you work on a specific file, only then the file can be on your, actually on your computer. So you could end up only with 8 files on your computer, and everything else is remote. So now there is the question of accessing this repository. How do you access it? So we said that Piper was the actual storage, and now you are a developer and you want to access this repository. And this is where CITC comes into play, CITC. So you're a client, you are connecting to the Piper with the help of CITC, which is a cloud-based storage backend and Linux-only fused file system. Developer sees the actual workspace as directories on their file system, and it's actually like an overlay over the full repository, which is the actual Piper. So in a usual use case, you have 10 files on your computer, only the files that you are working on. The general Piper workflow is that you sync your workspace to the repository, you then write some code, you then submit it to some code review, and then there is a commit. Standard workflow. There is also the concept there of an auto-commit, because when you submit your code to code review, then you can check in a checkbox that you want an auto-commit, or just mention it in the command line. And then if a developer from a different time zone, for example in the middle of the night, which for him is morning, is doing the code review and he approves it, and you can mark it for automatic merge. So far, we have only described this large monorepo and the work process, but how do they actually manage to successfully work with such monorepo, and why is it a success for them? Why do they consider it a better option than separate repositories? And later on, we'll discuss the disadvantages. So the advantages of this is that we are working on a trunk-based development. This is how they work. They work with the trunk-based development. In this workflow, almost everybody are working on the head. It's sometimes called the trunk, and it's sometimes called the mainline, which basically means that it's almost as if you are a single developer. You are working on the master branch, you are working on the trunk branch. Each commit is serially coming after the next commit. What do you see in this? You see that this is very simple because instead of having multiple branches and each one is working on his feature branch, and then you need to merge everything and you have collisions, you always work on the latest repository source code and you merge to the latest repository source code. This is much simpler. If you have worked in teams that work with branches, then you know the pain of doing all the merges. At this point, you really want to work with the trunk-based development, and this is a great choice that they have made out there in Google to work in the trunk-based development methodology. It simplifies so many things. So just imagine if they had this monorepo and they had branches. It would be a nightmare. Okay, it simply cannot work. So they practically had to adopt this trunk-based development. Also, they said that in order to avoid the branches and in order to have the trunk-based development, they use conditional flags in the code. So when you submit a code into the code base, you wrap it up first with the feature toggles, then you enable it, and then when everything is stable, you just remove these feature toggles, and this removes you from the need to create multiple branches and all the merging hell that can appear if you work with multiple branches. It's always good. This trunk-based methodology is just great. So you have thousands of engineers committing. Even if you work in the single master branch, single trunk branch, you still have thousands of developers committing to your code base, assuming you have this mega repository. This means that you must have a very good set of automated tests. And this is one of the things that they hugely invested in and developed. If you commit something, if you test something, then there are a lot of test suites that run and check that it's okay to commit it. So you can have high assurance in committing it. And you must have this. If you have a repository with so many developers, with so many commits, you must have this kind of tests. It's just unavoidable. You wouldn't be able to work without it. So it's implicitly that you have it. And also in general, now I think we have reached the greatest benefit with the monorepo. The greatest benefit with the monorepo is that it's so visible. You can look everywhere. You can use your IDE and search for all the references. The search can be much more better because everything is connected and related. You don't need to guess which other modules are using this method. If you want to refactory name a method, you can practically refactory name it in hundreds of places. So this is the great benefit of using the monorepo. The greatest benefit is the visibility and your ability to see so many places and your ability to do such refactors and your ability to do a very high standard static analysis for the code, a system that they developed that is called tricorder. In the paper, they also described in general that when they develop features inside this code base, then first they make a large backward compatible change first, and then when the change is stable, they make a second smaller change that can be made in order to remove the original pattern that is no longer a reference. They also have another system which is named ROSI, which takes care of splitting large commits and large patches into smaller patches so that they can do code review for smaller commits, smaller chunks of commits, because if you're doing code review and you see 50 files, then you'll be more reluctant to do this code review than if you see a single file. So they have this rosy system, which makes things much rosier. It splits CR into much smaller ones. Also, they have code ownership. So if you do a change to a specific directory, then there is a team that owns it, and they would most probably do this code review, and I'm sure it's standing notification, and you can automatically see who is the owner of this part of the system, because if you had multiple repositories, then you can see this, because each repository would have the owners. But now that you have all the monorepository, you need to be able to detect who are the owners. So this is part of the tool set that they have development. So to sum up, Google has developed a number of practices and tools to support its enormous monolithic. They distributed the repository, all the sources, through the Piper and through CTC. And they have additional tools such as Critique, Code Search, and Tricoder, and Rosie that they have developed in order to support all this large operation. So let's summarize the advantages of this huge monorepo. So first, it's a unified versioning, one source of truth in a single place. It has an extensive code sharing and reuse, a simplified dependency management. You can do atomic changes, so you don't need to change one repository and then another repository. It's a single commit. It could be a single commit. Large-scale refactorings work beautifully. Collaborations across teams, you see all the code, flexibility, teams boundaries, and code ownership. So on one side you have the code ownership, or on the other hand, the code is visible for you to change, and code visibility and clear tree structure, which provides you with the ability to understand what's going on in the code base. And if one team wants to depend on another team code, then it can depend on it just directly. Also, I think they also include all the internal libraries. So if they include like Apache Commons, then I think they actually include their source code in this monorepo. So just think of it. If you have collisions, if you have the diamond problem, where you have one code base dependent on one version and another code base dependent on different version, and you need to have both of these, then they don't have this problem because they actually have the actual source of the dependent version. So they never have like two versions unless you explicitly rename the class name to have a specific version, which is not that best practice, but it could be. Okay, it could appear probably in the source code, but if two teams like rely on Apache Commons, then most probably they would rely on the same version. This would also resolve a very huge problem of collisions that you might have when you work with just libraries. The layout of the code is, you can just see it, so it's organized in a very well manner. So there are a lot of advantages to this single mono repo. And you can take like a snapshot of everything. You can take a simple snapshot of all the mono repo. And now for the trade-offs, for the disadvantages of using this large monorepo. So first, they needed to do a lot of tooling investment. In the paper, they described all the tools that they are using, as we said, Cody, Rosie, and the Piper, and the Sitsi, and additional tools. So you need to have a lot of investments. It costs you a lot, but if you're smaller, then it would not cost that much, and you might not need even to create these tools. And there is the code base complexity. There is a large code base to handle, and it has its inherent complexity. And you need to invest a lot of effort to check all the code health. Also, when you use an IDE, you can't just load everything into the IDE, so you need to develop special plugins which are aware of this large repository. Also, if another disadvantage, if you work on such a large code base, then this would mean that you would de facto be less likely, unless you psychologically really think of it, you will probably less likely to do a real separation in between the modules. Okay, so you have either to enforce it, because if you are using multiple repositories, in most instances, you are treating one repository as a library, another repository as the service, etc. But now that you have a single repository, you might create a mess. So you need to have either the tools to assure that you're not creating a mess in this one giant repository, or do very strict interviews like they do, in order to make sure that the coders that they have are people that are aware of all these implications and would not try to do a mess in the code base. So teams could just not think about their dependency graph, which is a good thing, but also a bad thing, because if you don't think about your dependency graph, then you invest less time. You just immediately include the call to a library here, because you just call it. It's already there. But if you need to include this library, then you do think, hey, I need to include this library. Do I really need it? So there are disadvantages to this model. And also, if multiple teams are using open source, they need to collaborate because they need to use the same revision of the open source. So if one team wants to upgrade, he needs to collaborate with the other teams. But I think the advantage of using single versions is much better than letting each team use different libraries. This is just my personal opinion about this. I like the strictness and simplicity of single versions, single libraries. Google basically in the past, in 2015, considered moving from Piper into Git. And they actually use Git in the Android and in Chrome. But it's a little bit problematic to actually use Git for this large monorepo. And also you need to remember that the kernel is also a good example. The Linux kernel is another good example that monorepo could work. So even before Google has adopted this whole monorepo, they could look already at the Linux kernel and say, this is working there. This is working there where you have many developers spread around the world and they have a monorepo. So maybe it could also work for us. And with that, let's conclude. Google chose the monolithic source management strategy back in 1999. When the existing Google codebase was migrated from CVS to Preforce. Early Google engineers maintained that a single repository was strictly better than splitting up the codebase, though at the time they did not anticipate the future scale, the future exponential growth of the codebase and all the supporting tooling that would be built to make the scaling easier. Over the years, as the investment required to continue scaling, the centralized repository already grew, and Google leadership occasionally considered whether it could make sense to move from the monolith model. Despite the effort required, Google repeatedly chose to stick with the central repository due to its advantages, and the monolithic model of source code management is not for everyone. It is best suited to organizations like Google. With an open and collaborative culture, it would not work well for organizations where large parts of the codebase are private or hidden between groups. At Google, they have found that with some investment, the monolithic model of the source management can scale successfully to codebase with more than 1 billion files, 35 million commits, and thousands of users around the globe. As the scale and the complexity of the projects, both inside and outside of Google, continues to grow, they hope that in this research paper that they published, the analysis and the workflow described can benefit other engineers writing decisions about the long-term structure of their codebase. And with that, we have finished the review of the paper released by Google, which is called Why Google Stores Billions of Lines of Code Inside a Single Repository, which was published by Rachel Potvin and Josh Levenberg in 2015.